Hi, welcome back to the webinar series of Analyze MyWorkpiece Toolpath. My name is Oliver and I'm the product manager for Analyze MyWorkpiece Toolpath. This is the second webinar, which is all about interacting with an imported point cloud into Toolpath. And this webinar is a part of a series of webinars, so make sure that you all watch them. The preceding webinar was all about importing data and getting data into Toolpath so that you can create point clouds. So make sure that you also watch that in case you need to learn how to import data into Toolpath. Okay, so much for the introduction. Now let's get directly started. In this webinar, we will talk about this menu here on the right side. So a precondition is that you already opened up Toolpath and that you also already imported a point cloud. In this example, you see we imported a part program, here an MPF file, which I simply dragged into the scene, and probably you already know it from the preceding webinar. This is a spiral, and we will use this example to learn how to interact with the buttons here on the right. So let's get started. The first two buttons are actually quite self-explanatory if you click them. So this one here changes the point size of the points in your scene. So in case you have imported several models into the scene, it is always affecting the whole scene. And by clicking with the left mouse button on it, you increase the point size, and you can increase it even further. So the more I click, the more often also the point size increases. And if you think it's now a good idea to reduce the point size, then you can do this by doing a right click. So left click increases it, right click decreases it. This can become quite helpful if you would like to create screenshots of your scene. As an example, what sometimes I use is this button here on the bottom right. It creates screenshots, and if there is a situation where you need it in a PowerPoint or something similar, I suggest to make it a bit smaller and make the point size a little bit bigger than the default. So by default it's like that. That could be too small, so I make it 2 clicks bigger. Then I click on this button, save screenshot. And now the screenshot is with the bigger point cloud size. And it's quite helpful because in PowerPoint, of course, you do not always have the room for big screenshots. And when you shrink the size of the screenshot and the point cloud is quite big, you are still able to see all the necessary information. So let's resize this. So much for the size of the point cloud. And the second button here is changing the line size. So could be that sometimes you want to have a thicker line size when your scene is probably a little bit like that it's not so dense and you want to easily see the lines. Then you can use the second button. It does pretty much the same thing as the first button. So left click increases the size and right click decreases the size. And now we have this button here. This is quite an important one. Oh no, let's start with that one here, the third one from top. It shows and visualizes the tool orientation vector. So in case your data set contains data about the tool orientation, then you can use this button to make this orientation visible. In this MPF file which we have here, let's just check the code, and we will talk about this area here later, but just for now, going to the G-code list, we can see the G-code of this MPF file, and we see that it does not only contain the X, Y, Z information, but also ABC. And that means that Toolpath understands how the toolpath is actually oriented. And that means by clicking on this button once or a couple of times, you start to see the tool orientation vectors. And here's the same rule: the more you click, the longer the vectors become. And if I do a right click on it, then the size decreases again. And yeah, as you can see here, we now can see the orientation of the tool. So in this case, it's a robotic case, so the end effector is moved concentrically like that. And why should you use this? It can become quite helpful in case if you have an area where the orientation changes very, very quickly. This could happen in a 5-axis machining case as an example, and you would like to understand why in the real process data you recognize a speed decrease. Then it is always worth checking the tool orientation, because if it changes quickly within a few interpolation points, then this could be a reason why there are speed drops in your actual process data. So always make sure to check it in case you have process issues in terms of abrupt speed decreases. So the next button we have here on the right below the tool orientation is the curvature. And if we click it once, we see the curvature for the whole scene. So for each point, the curvature can be calculated using the edges and points. And the curvature actually reveals also very important information. It will tell you how smooth the movement of your mechanic will be by following this toolpath. And well, from its functionality, it works the same. The more I click, the longer the vectors become. And let me just show you now an example where you can see a lot about the curvature. So let's import another file. And I will import it into a new scene. And yeah, let's just connect the two scenes so that we can better compare it. And on the right, let's visualize the curvature again. So here on the right, we have areas where the curvature is not really steady. And let's try to focus on these. How do we do that? We hold down the shift button on the keyboard, the left shift. And while holding it, we also hold down the mouse button and we drag this rectangle here. And let's just look at these two areas. And let's choose the same ones here. And we can directly see at a glance that there is a big difference. So the curvature is not really steady here. And even if we check it how it is distributed alongside the plane, we also can see that on the right the situation doesn't look really good. And yeah, therefore the curvature will reveal that we can expect speed drops here in this area, because the mechanic will try to follow this path like that, and that will slow down certain axes. In another webinar we will have a closer look at this example where we can see this direct connection. For now, just be informed that yeah, with this button you can visualize the curvature, and when you see irregular behavior like that, this could be an indicator that something is odd with your toolpath. If I deselect the points now, I can see the curvature on every point in my scene. And if I would like to do the focus in a different way, what also works is making the sub-selection first and then visualize the curvature. Now let's come to the next button. This is one more here at the bottom, is the custom vector. So with Toolpath you're not only limited to visualize the tool orientation and the curvature, you can also use custom data in order to visualize it as a vectorial size. So let's first import the new data. We take this recording here again. I will create a new scene. That's why I put the file here. So first of all, we select the 3 components, and now in the drop-down we don't see current. So again, what do? We can simply remove the text here and write current. And what is now very important is you have to write 3 times the same name, and only then Toolpath understands that this is a vectorial data set. If you do something like that, current 1, 2, 3, you can do it, and you can also perform analysis, which I will show later on, but it will not be understood as a custom vector data, so therefore you should give it the same name. And now let's click the import button. And here we see it now in a new scene. Let's make it big and zoom into an area. And now let's just click this button. And now a new vector comes along. And this is our custom vector. In this case, it's resembling the current of the motors. And again, the more I click, the bigger it gets. So you also see the current here. So basically you're not limited to visualize only orientation, curvature. You can import any data. So it could be also force sensors as an example, whatever you would like to find out. Coming to the next button, this is the ABC. Yeah, orientation basically. Let's go back to the spiral again. So in case you have a NC program containing ABC information, like here, you can also visualize that. And so let's unselect all points first. And now we see it looks a little bit wild, but this also helps you to detect areas where you have quickly changing orientation, a little bit like the tool orientation. And these are the ones you would like to should look for, because again, areas like that could show you, okay, there is a quick change of orientation, especially in this area. Let's just select these few points here. And here we see there is a very quick change of orientation, and this in the end will also be probably visible on the workpiece you are producing. So in the end, it's always about which problem do you want to serve and solve. And sometimes it's a little bit about exploring and finding out the root cause. But using vectorial data, it should be much easier to understand where certain problems could have occurred. Then we have here one button more. This is quite self-explanatory. It allows you to visualize the coordinate system, the X, Y, Z directions, and then we have this show more lights button. It does not work with point clouds only. You should implement STL files. So with Toolpath, you can also visualize STL files. Let me come up with an example here. So first of all, let's close these scenes. And let's import this test STL file here. So STL files can also simply be dragged into Toolpath. And okay, this is quite a simple geometry, but I only would like to show using this button you can increase or decrease the brightness a little bit. And sometimes it's helpful if you are looking for surface disturbances that with using different lighting, yeah, could be easier to understand whether there are disturbances on the surface. Okay, let's close this and let's just import some points again. We are nearly through this whole menu, so these are the points for the STL which you have just seen. So by the way, if we take the STL and put it into the same scene, we now see the points on the STL. And let's just remove the STL for a second. So let's come to the bottom with this eye symbol here. It says show only selected points. So first of all, if you do a sub-selection of the points, click it, and then you end up in a new kind of virtual scene where only the selected points are visible. And if you want to see the other points again, then you just, simply have to click the I button again. So it can be quite helpful in terms you have a very complex workpiece and you want to put the focus on a certain area, then you can use this to only work in this area. And in this area you have all the other functionalities again. So you can select subsets and select the orientation or curvature. Let's say quite self-explanatory. Then we have this button here, select all points between first and last selected point. Also here, in case you have quite a complex part like a mold and die part. So this could be a mold and die part, and you are interested in what is happening between here and here, and you don't want to select all those points manually now. Just click 2 points, click here, which says select all points between first and the last selected points, and then Toolpath does exactly that. All the points that are in between are now gonna be selected. Then here you can deselect the points, the same as putting on the keyboard the N button, like North Pole. So if you click either N on the keyboard, or if you click this button here, it says deselect points. The last button here is a little bit useful when you have a, let's say, not so powerful system. As you might have noticed, when I rotate the scene, the points disappear, so we only see the lines. And this is, sometimes you don't want this to be like that, so you can let the points be visible while rotating. But let's say with more complex workpieces, it can be that the performance of your system reaches let's say a critical level, and you can't really rotate anymore through the scene in a very accurate manner. Then you want to click this button here, and then you save some performance and you can more easily rotate through the scene. Let's finish this webinar with this area here. So we have what we see in this window basically is a smaller representation of the whole scene, and we see this red square or rectangle telling us where exactly we are in the workpiece. So it could be that you are very, very close, zoom very close, and you want to understand where you actually are. So this can be, and you learn where am I in my workpiece currently. And something about orientation. So assuming you are zoomed in very closely, let's just increase the point size for now. And you want to rotate, let's say, around this point. And Toolpath is obviously currently not rotating around this point. The only thing you need to do is you double click the point. Now this is the center, and this is now the point around the whole scene rotates. And it doesn't matter whether we are very close or whether we zoom out. Toolpath remains this point to be rotated around. Let's click N and deselect the point. Then we have self-explanatory buttons here: fit to screen, or fit to selection. So if we have a selection here, then it gets fitted to that selection. We can also zoom in by buttons if we don't want to do it using the mouse wheel. Then we have this camera symbol here. We have always the home position on this home button, bringing us back to the home position. And then we have pre-configured orientations we can access here, like from left, right, top, bottom, and the two sides. Then we had this chain, which you have also seen in another example. So let's just repeat it again. First of all, let's import the STL in a new scene. And let's just orient them like that. And if I click the chain here in both scenes now, both scenes are synchronized in terms of orientation and also movement. Okay, and then the very last button is that one here on the right. It says save screenshot. So if you have executed an analysis and the result you would like to show on PowerPoint or via email or put into a Word file, Toolpath can create a screenshot out of the scene as it is. So as I recommend, if you want to do that, you should increase the point size. And to finish it, let's make this very colorful. So I increase the line thickness a little bit, and let's just bring in some color coding here. How you do that I will show you in the next webinar. For now, let's just make this super colorful and create a screenshot here. And we can now show additional information on the screenshot if we want to, like date, time. So now we know when this screenshot was created, and if we can now copy it into the clipboard. So if you want to directly paste it into your document, you can use the copy icon, or you can save it and simply put it where you need it, and then the screenshot gets saved. So with this very colorful picture, I would like to finish with this webinar, which was all about the menu here on the right. I hope once more that you've learned a lot, and hope to see you in the next webinar, which will be all about this area here and containing lots of helpful functionalities in order to optimize your manufacturing processes. Thank you very much, and yeah, see you in the next webinar.